Hi, everybody. Welcome to our monthly lecture for Geoscience Analyst here. As a reminder, as always, this lecture is being recorded and will be made available on our YouTube channel in the following days here after we're done talking. My name is Sean O'Connor. I'm a senior geologist here at Mirror Geoscience, and I'm pleased to introduce our speaker today, Jennifer Levitt. Jennifer is the product manager for Geoscience Analyst, and she's going to show us some of the new drill hole design and monitoring functionalities that are coming around in Geoscience ANALYST Pro version 4.0. If you have any questions during the presentation, feel free to type them into the Q&A box in Zoom or raise your hand. And for those of you on LinkedIn, type them into the comments section and they're going to get sent across to Jennifer and I for answering after Jennifer is done showing you everything. All questions will be answered, within reason. There's certain things we can't help you with, but please be aware that Jennifer might wait until the end to answer your question, and in all likelihood will. Jennifer, please take it away. Thanks. I'm going to turn my video off here.
Thanks, Sean. Welcome everybody for joining us today. Today, as Sean said, I'll be taking you through the new drill hole designer tools and monitoring functionality that we have in our upcoming Geoscience Analyst Pro 4.0. I'll get straight into it. So as though I was going to plan a drill hole in Geoscience Analyst, here we just have our regular Flin-Flon demonstration data set. I have a target that I've already generated on an ore body here. And I'll be using that target to generate or plan my drill hole, or a drill hole. So within our drill holes menu, we have quite a few new tools in here. Drill hole designer has been around for a while. Here we've actually extended upon some existing functionality and added new ways to plan drill holes directly within our viewport. We have target to surface to calculate a drill hole from a target location to, say, our topography, to maybe better locate a drill hole collar from a non-desirable location, a direct collar to target tool, straight line between 2 points, collar to a targeted surface, so from a collar location to a lithological contact, such as something like this. Direct collar down tool. Now we have the ability to model or estimate drill hole corrections using wedges. And I was always able to copy an existing drill hole. So I'm going to very quickly just do a target to surface. So here is my target. I'm going to nominate my surface that I'm going to be putting my collar on. It's my topo, and then my target here, my new target. Majority of our tools now have a preview of the drill hole path that we're planning. The preview is always the maximum path length, so it may look like it extends above our topography. That will not be our final drill hole. This preview updates in live time, so I can change the lift and swing of the drill hole, and you can see the actual path of that, or the preview path, updating in real time. So I'll bring this back to a straight hole. And the initial preview is always at a drill hole target plane of 90 degrees. That I can also adjust to an azimuth or a dip as I would wish. And the drill hole target plane angle also updates. Now, it would be really nice if all of our drill holes were always straight, but they're not. And in implementing lift and swing into our drill hole planning, we've also added a tool to analyze drill hole paths. So our drill hole statistics tool, either from our drill holes menu or directly from within our drill hole designer. So this will pop up that interface And what this will do is we'll show all of our drill holes, allow all of those to be applied to the filter, and then we can decide how we're going to actually select our drill holes. We can pick them directly from the drop down, or I can say I want to pick the holes that are within sort of a buffer here. So I'm just going to quickly set my buffer to be nearby my target. So as I do that, you can see the buffer is highlighted, and the drill holes that are contained within that buffer are also made visible in the viewport. I can pick those drill holes, so I can then come in and select which holes I actually want to use in my query. These ones. And then when I click statistics, it's going to report the basic statistics for the lift and swing of those selected drill holes, as well as the initial dip and azimuth of the holes as well. So I can use this information directly within my drill hole designer to actually try to better plan my drill hole. So I'm going to put in that, and I will just put in a swing, if just a smallish swing of say 1 degree here. Filtering also options by drill hole orientation, or the initial, the collar, azimuth, and dip of those drill holes. So if I'm actually going to try and have a specific angle of attack, then I can query those particular drill holes, as well as computing drill hole behavior below a nominated depth. All of this information can be copy pasted elsewhere, so we can keep that for our records as to how we have decided the inputs for this particular drill hole that we've been planning. So there's my planned drill hole. I can also include a tolerance for the orientation at the target, so I can increase this, and this will allow us to suggest a series of drill holes that we can then choose or use to actually create our planned drill hole. This would be used, this particular tool we feel is useful if, say, you need to collar near a tenement boundary and you can't actually drill out, you can't put your drill rig outside of that, or on if there's any geographical areas that are not suitable to place your drill rig. I'm just going to bring these back to 0 and take my default drill hole. So once I generate this drill hole, it brings up our manual drill hole designer. This is very standard from previous versions of Geoscience Analyst. However, we do get, as we had before, the azimuth or the XYZ, and then the collar, azimuth, and dip of this particular drill hole. We can define that drill hole to extend past the intersection of the target, and we can also specify what type of drill hole this is, and this is our planned drill hole. So when I click create, I can close these. I have a planned drill hole. This particular drill hole can then be exported along with any other holes that we've planned into a just ASCII CSV, where you would actually have a list of the collars, list of the collars information, the length of the holes, etc., as well as, I guess, the survey file for those particular holes. So that is a quick demo of the planning, or one of the planning tools that we have, as well as the analysis of existing drill holes or nearby drill holes to help us in better planning our holes. So on to the monitoring. If we have a planned drill hole and we actively start to drill that particular target, then we can actually import the ongoing hole and link them, and then look in 3D with some other tools to see how well that hole is progressing to hit the target. So I'm just going to very quickly import an ongoing hole just from straight ASCII files. And this can be done very easily, either from just a simple ASCII CSV file, but also once the initial ongoing hole has been imported, they can be updated within the manual drill hole designer. We can just hand enter survey stations and watch the drill hole progress within the viewport. So I'm just going to click on apply. The drill hole collar, we've already set this as status as ongoing, but that can be done internally within Geoscience Analyst as well. So I'm just going to click OK for that, OK for that. And here is our ongoing drill hole. I'll just move him into the monitoring folder where I have my planned hole and link these two drill holes. So these guys now know that they are together. The ongoing holes, we have a very specific visualization for these. So all of the survey stations that we have are actually a solid line, and below that, the drill hole is extended to the end of hole as specified in the collar file with a dashed line, and it's projected to the length of the hole. So I can look at the two holes together and see how well my ongoing hole is coming towards the actual target that I have. To assist in this, rather than having a straight 3D view, we also have implemented a monitoring panel. And this panel gives us 3 predefined views for our drill holes. So we have a section view, so a straight plain section of our planned hole. We have a plan view, a map view, and then we have also another view which is perpendicular to the target. So we can directly see how well our hole is approaching the target location. The target object has a new visual parameter where we can display it as concentric circles at a user specified interval. These ones are at 10 meters. So we can very quickly see how far, just in like eyeball, how far our drill hole is away from the actual target. As the drill hole progresses, we can update the path. So I just specify I want to update an existing drill hole group, and it's going to be my monitoring drill hole group. And if I just pick I'm just going to pick my third set of survey stations. So this is just an extension as though you had been updating your survey file. We'll click on OK, and the drill hole will update. The solid line will continue down to your last station, and then it will continue as a dashed line. And this will be not only in the monitoring panel, but in the viewport as well. And as I said, we can always open up the manual drill hole designer and add survey stations as we go manually without actually going through a file. I'll quickly show also, if we had decided to correct this particular drill hole, we can come back to our drill hole designer and select to insert a wedge. So here we would pick our parent hole. I'm just going to hide my planned hole and pick my parent hole as my ongoing. And so parent hole, our location of our wedge is going to be at the point that we picked. It reports the azimuth and dip. And then here, this is where we actually implement the wedge itself. So we have a predefined wedge angle, and then we can define the rotation angle, and then also the lift and swing of the drill hole. That seems a little extreme. Let's bring this back down like that. So as we update the rotation or the roll of the wedge, we can look at the update. We can sort of scroll this around, or we can enter the values as to how we want to place the wedge in the drill hole. And this is where, again, the lift and swing stats tool can come in handy, because then we can actually look at other drill holes that may have had wedges placed in them, or drill holes that were just below that depth, to look at, again, lift and swing behaviors, so we can better plan or project drill hole behavior after we've actually implemented the wedge. The wedge has two options here. We have a correction wedge, where basically the drill hole path will continue and we'll just get a new drill hole, or a branch wedge, where effectively we're just putting in a branch or multiple branches off of an existing drill hole, at which point the drill hole collar will just be placed at that location. But it does the same thing. We literally just click on generate. We get a new manual drill hole designer. The wedge itself is placed and highlighted in the table, and then the new drill hole would be created. And it was a short and sweet demo, but I will welcome any questions that you guys may have about any functionalities that you've seen here. And yes, thank you very much.
Well, thank you, Jennifer. That's pretty interesting looking stuff, and I like the bullseye view especially. That's pretty slick. Came together really nicely. Something very satisfying about watching that change as you turn the rotation on the wedge.
You were very helpful in actually implementing some of those views and some of these ideas, Sean.
Well, I appreciate that. It's they've survived in spite of that. For those of you who are in the lecture, we will give you a half a minute here, a minute to type in any questions that you might have, again, down in that Q&A box in Zoom. But if you do have any questions in the future, as always, you can email us at support@mirageoscience.com. In the meantime, I will say a shameless plug. I'm coming back at you next week to talk a little bit about scripting and some exploratory modeling stuff in GoCAD Mining Suite, totally unrelated to what Jennifer's talking about today. But next month, Carla Gonzalez is going to come back on and show you some other new features in Geoscience Analyst version 4.0, which will be dropping sometime in June, I think.
Yeah, you'll be able to see, you'll be able to come and visit our team at PDAC. They'll be they'll have all the tools there. And if you have any questions about functionality, about Geoscience Analyst or GoCAD or any of our other products, then we'll have the team there for you to talk to.
Yeah, right on. Summer PDAC. It's happening. Okay, well, so we do have one question. I think this one's coming in from LinkedIn, and this is from Nezi Domrao. Their question is as follows: How does the software calculate the deviation? And for example, if we put a lift value of 0.3 and a swing value of 0.5, let's say every 25 meters. I think I saw in the software that it's specified in every 100 meters, but the concept of the question is the same. Does that calculation start at 0? And I think here what Nezi means is the hole deviated between 0 and like the first deviation station, or am I misunderstanding how this works, Jennifer?
So I think the lift and swing is basically implemented from, I guess, the top or from the end of the casing. So if you put the casing to say 5, then the lift and swing starts to calculate at 5, but it's per 100 meters down the drill hole. So the station interval is how often you want to create survey stations on the drill hole. So you can set that at any interval you like. We just set a default of 50, but it could be, I don't know, 79 if you wanted. So regardless of the station interval, lift and swing is always calculated per 100 meters.
Okay, thank you, Jennifer. There's another question in the chat, just an administrative one from an Adam White. And Adam asks if it would be possible to share the recording with us so we can share it with their team. The answer is, of course, yes. It's going to go up on YouTube in the next couple of days here once we clean it all up. And we'll get a link posted to that on LinkedIn, I believe. And you can check that on YouTube at your convenience.
Yep. I also recommend we post all of our videos and webinars on YouTube. So even if you may miss an invitation or one of our videos, they're all there. So I invite you to go and subscribe to our YouTube channel, click the notification bell, and you'll never miss out on anything. It's actually a good resource. There's a lot of tools in there, and lots of our support questions get linked back to videos that we've placed in our YouTube channel.
Yeah, absolutely. Well, it doesn't look like we're getting any more questions coming through right now, Jennifer. So maybe we'll leave it there for today. But as we said before, feel free to send us an email at support@metergeoscience.com or slide into those YouTube comments. And we can't promise we're going to answer those questions, but you had your chance.
Oh, they always get answered.
They always get answered. There you go. And thanks everyone again for joining us. And thank you especially to Jennifer and the rest of the Geoscience Analyst team here. This is looking really great. And we'll talk to you all again soon.
Awesome. Thank you.
Thanks
Bye.
very much. Bye-bye.